Greetings everyone, my name is Mark. I'm a high school student and I'm aspiring to become a quant. I enjoy math and finance and everything in between. And I'm recording these videos because when you try to explain something to someone or when you repeat information that you already know, you get a deeper understanding of it. And when you try to explain something to someone, you remember about 90% of the things that you talk about. Whereas if you only write down or read your notes, you only remember about 5%. So that's why I'm doing these videos, to have a deeper and better understanding of the given topic. And since that I'm already recording this, which is mainly for myself, and if I ever get stuck, I'll just return back to it. And since that I'm already recording this, I might as well share it, and someone might find it useful. I plan to cover multiple topics, from simple mathematics to complex quantitative methods, and today we're looking at a problem from set theory with multiple set analysis. And the problem is as follows. There are squares and circles drawn on a piece of paper. Every shape is either green or red. There are 9 green squares. There's 3 less circles than squares. There are 3 times as many squares as red circles. There are 7 red shapes. How many green shapes are there on the piece of paper? So there's the problem right there on the top left for those who need it. And essentially, we will start out by writing down the things that we know and that are given. And since that this is a problem from set theory, we are expecting to use the Venn diagram. So therefore, there has to be a relationship between the elements, which are given, the elements in one set and in the other set, and some elements that are in the intersection that have properties of both. So here, essentially, it'll be a question of shapes and colors. So first of all, we need to determine that we have the right set. So if we would have, let's say, the set of squares and circles, well, then there wouldn't be a common intersection, because if, let's say, we would have the red circles here and the green circles in the intersection, that wouldn't really make sense, since that circles aren't squares. So we can either go for shape and shape, like the relationship between the sets, shape and shape, or color and color, which wouldn't make sense either. So we have to go for shape and color. So in one set, we will have the color of certain shapes, and in the other set, we will have a given shape. But before we do that, let's write down the things that we already know. So there are 7 red shapes. So we're going to write down R for red. There's 7 of them. Then we have green. That's what we're trying to find out. There we go. And now we're going to have to find a unknown variable from which we will be deriving the other ones. I chose the red circles as the as x, as the unknown constant, or whatever you want to call it. So yeah, so we have squares, then we have circles, and then to keep things organized, we're gonna go for the red shapes first. So that's our red squares, then we have our red circles, and then lastly we have the green squares and the red circles. Oops, not red circles, green circles. Sorry about that. There we go. So for me, X will be the red circles, just like so. There's also stated that there are 9 green squares, so we can pop that right there. There are 3 times as many squares as red circles, so we can go here to S for squares, so that's 3x. And there are 3 less circles than squares, just like so. So that'll be 3x minus 3, because 3x is for squares, and circles is minus 3. So that's pretty much it, what we can get from the problem itself. So we're gonna have to figure out the red circles and the green circles and the green shapes, which is also the question. So what you could do here is drawing out all the combinations of the Venn diagram with all the colors and the shapes. So you can have the red shapes and the squares, just like so. So over here, there are 7 red shapes. And here, there are 9 squares, which are green. There's 9 of them. These 9 squares belong to this part of the Venn diagram, not to the intersection. Why? Well, because elements which are in the intersection need to correspond to both sets. So first of all, they have to be a square, and second of all, they have to be red. We also know that there are 3x squares. So naturally, if there are 3x squares and there are 9 green squares, well then the red squares will be 3x minus 9. Just like so. Sorry, not the green squares, the red squares. So that'll be 3x minus 9. So that's our first combination. Our second combination are the red shapes and the circles. So first we have the red shapes and the squares. Now we're gonna have the red shapes and the circles. Sorry for my bad drawing. There we go. So as mentioned before, there are 7 of them. So R is 7. Then these circles are 3x minus 3, just like so. And the red circles are simply x. That's our x. And if we wanted to, we can also figure out the green circles, which is right here. That's actually quite important, and that is simply all the elements in set C, if you will, in this set right here, where are the circles, minus x, so that's minus the intersection. So that would be 3x minus 3 minus x, and that can be simplified to 2x minus 3. So there are 2x minus 3 green circles. So now we've got everything. However, there are still 2 more combinations for those who are curious, which we can use. And you can use any of these 4 to get to the solution. You don't really have to, there's not really a certain pattern or way, and you don't really have to use all of them. I'm just gonna show them for those who want to know. So oops, not a red, sorry. Because we already did the red ones, so now we're gonna do the green ones. So we're gonna go with G, and that's unknown. That's what we're trying to figure out. So we have the green squares. So there's 9 of those, just like right here. And overall, there are 3x squares, which means that there is 3x minus 9 red squares. 3x minus 9. Because you're taking the whole set minus the ones which are in the intersection. Just like so. And then our fourth and final combination are the green shapes and the circles. Just like so. Again, green is unknown, the green shapes are unknown, that's what we're trying to find out. So the circles are equal to 3x minus 3. We know that the green circles are 2x minus 3 because we figured that out thanks to this Venn diagram right over here. So that's 2x minus 3. Next time I'll draw the intersections bigger. So that's the intersection. And yeah. So those are the green circles, and the red circles are quite self-explanatory. That's just equal to x. We've got that here. So if we think about it, we can solve using these Venn diagrams as multiple Venn diagram analysis for x. So thanks to this Venn diagram right here, for example, we can solve the elements which are exclusive to this. Okay, so why is that important? Because our x is the representative of the red circles. And this right here is the Venn diagram for circles and for the red shapes. So our red circles are x, right? That's I've already explained that. That's super quite easy. So now what we're gonna do is that we're gonna try to figure out this part of the diagram, which is only exclusive to red shapes. So or not red shapes, red squares. There we go, red squares. Because what we're gonna do is 7 minus x, which is this right here, and after taking this set and subtracting the intersection, we get the red squares. And this has to equal to something, because we're trying to solve for x. Well, if we look at our handy list of relationships, or relationships like the relationships between the terms, then we can see that the red squares are equal to 3x minus 9. So 7 minus x is equal to 3x minus 9, just like so. And after solving this equation, so that's plus x, 7 equals 4x minus 9, and that's plus 9, that's 16, x is equal to 4, just like so. We've solved for x. And you can do this with any other with any of these Venn diagrams if you have all the given information which you need for solving x. So you need to keep in mind that the part of the Venn diagram which you're trying to solve, for example, in this case it was the this part right here, which is only exclusive to red squares, needs to be equal to this term that you have right here. So it can't be any term, obviously. So and if we plug that in, x for 4, we figure out that there are 12 squares, 9 circles, 3 red squares, 4 red circles, that's what's equal for x, And what we're interested, or what's the question in the problem, or what we're trying to solve, that's 2 times 4, that's 8 minus 3 is 5 green circles. But the question is how many green shapes are on the piece of paper? So that'll be 9 plus 5 is equal to 14. And that'll be the answer. Okay, that's everything I have prepared for today. Enjoy the rest of your day and stay safe. Take care.